All right, AP Calculus, lesson 3-6. We're doing analytic analysis where we're talking about increasing, decreasing intervals and critical values, but without our graphs anymore. So, objective, who can read it?
Find where the function is increasing, decreasing, and critical values without a graph.
Basically what I just said. Okay, so let's talk about the F prime test. You guys are eventually going to be learning the F double prime test. Don't get them confused. There are 4 easy steps when it comes to taking the first derivative test, and that is to first draw some sort of x-axis, some sort of line. So draw x-axis. I cannot. There it goes. After you draw the x-axis, the first thing that you're going to find is your CV. So find your CVs. And by the way, what is a CV? Give me the definition. FCV is?
Where f prime is equal to 0 or f prime is not exist.
0 or f prime DNE. All right, you should know that. I'll write it down again. Say again?
He knows what the 10 next actually wrote bracks instead of draw.
Oh.
I don't know.
And then next you need to test points on either side of the CV to figure out if you're increasing or decreasing. So test points.
Is this a calculator thing or?
No calculator. Test points, and then I'll put in parentheses here because this I'm adding on from last year. On sides of the CV, a very critical value, and finally make some sort of conclusion. So conclusion. So I guess example 1 and example 2 aren't typical AP questions. AP questions would give you some function f. You'd have to take the derivative because it's asking where is this function f increasing and decreasing. Something like that. And usually a multiple choice question would be where is f increasing? You have a bunch of different possible intervals to choose from. So I took the derivative for you. I just want to purely focus on doing these steps with the first derivative test. So I already took the derivative. It's negative 3x. So let's find all of these values. Let's find the CVs and increasing and decreasing. I'm just doing the objective today. So what am I doing?
You are drawing an x-axis.
Let's do it. Draw an x-axis. Skip like at least one line. We're going to need some room. Nice and big. Right there is our x-axis. Okay. And if we're being formal about it, we can say that is our x-axis. All right. So next. All right. So CVs. Where are CVs for this function? 0. Yeah. Where is f prime equal to 0? Well, I set f prime equal to 0, so I say to find CVs, I can make this a little bit more organized than last year. So if I find the CVs, I'm doing 0 in the place of f prime, and that's equal to negative 3x. Therefore, x is equal to 0. 0 is the CV, the one and only CV. The only way that you can get something that does not exist, a DNE, is when I have a fraction with a variable in the denominator. That will give me a DNE. That's what I need to be careful of. Are we doing a sting? Oh.
Just a quick question for you.
Yeah.
Do you want to use my chart to get water?
That would be lovely if I could.
And then I got 5 of those 5-gallon buckets at home.
Oh, really?
I can try and race back and grab real quick.
That would be, yeah, that would be amazing.
Okay.
Thank you. Mr. Brown's looking out for us and cleaning the fish tank. We're going to get new water. So our CV is at 0. Just go ahead and make a random point. I'm just going to say, yeah, sure, there's 0. And let's label it. What thing did we just find? We found a critical value, a CV. All right, we're on step number 3. We're going to test points on either side of our CV. And if you have like an interval, you'd find here, here, and here. But since we only have 2 sides, I'm just going to test a point here and here. Just anywhere to the left and right. Choose nice numbers. So what's a nice number that's on the right side of a CV? 1. Okay, so I'll say 1. And what's a good number on the left?
Negative 1.
Yeah, sure. Those are good numbers. I mean, it's easy for this one, but if you had to choose between like 0 and like 2/3, you're like, what's a good number? I'm going to go with like 1/4, I guess. Yeah, it does get harder. Okay, so let's choose one and plug it into the derivative. So I need to make this because I remember last year we made this mistake. Into the derivative. into f prime. Don't plug into f, plug into f prime. Because we're trying to find increasing and decreasing intervals. It doesn't make sense to plug into f because you don't know if you're increasing or decreasing. If we plug into f prime and we get a positive number, it is increasing. If we plug into f prime and we get a negative number, you're decreasing. That's the main goal. So let's plug in 1 into f prime and we get negative. So we'll say down here, we got a negative. I don't care what number it was, we just know that it's negative.
Okay, so how do you get negative?
When we plug in 1 into x, into the derivative, negative 3 times 1 is negative 3, which is a negative number. What happens when we plug in negative 1, Gio?
It will be a positive.
It will be a positive. All right. If f prime is a positive arrow, what is that? Definition of f prime is positive. I'm giving you the definition. You need to give me the front of the flashcard. F prime positive means f is one of these three.
Oh, increasing.
F is increasing. So
Like,
f
isn't that just what you said though?
Increasing.
I couldn't figure out what you wanted. Okay.
Claire, when it's negative, f is decreasing. Done. Well, I guess done with our test points. We're now drawing our conclusion. So, our f CV, where did that happen?
And
X equals 0. Geo, where is f increasing?
At negative 1.
At negative 1 it is increasing, but at negative 2 it's increasing. At negative 0.25 it's increasing.
0 to negative infinity to 0.
Negative infinity to 0. There's your interval notation. If you like inequality notation, you can just say x is less than 0. And where is f decreasing? From 0 to infinity. From 0 to positive infinity. Or you can say with inequality notation, x is greater than 0. Done. Nice, easy example to get us started. And Arrow's like, oh yeah, this is way easy. I remember it being way harder. Huh?
I did not think that.
Oh, okay.
But that's because I wasn't thinking about what we're doing.
All right. I appreciate the honesty. Let's go and make another x-axis. Yoink. This is indeed our x-axis. You don't really need to label it. I just get in the habit of doing it all the way from Algebra 1. All right, so what are we doing? Try to not look at your steps. Try to remember what the steps are.
Try to
first, you're gonna find the CV. Or second, you're gonna find the CV.
Find your CV. All right. Find CV. So what am I setting equal to 0, Gio?
You setting 0.
Yeah, what should be changed to 0 in this equation? The left side, the x, the 4, what's being set equal to 0?
F.
Yeah, f prime of x. That whole thing is 0. So now I have 0 is equal to negative x squared plus 4. So far, so good. Solve. Subtract 4 on both sides. Divide by negative 1. I get 4 is equal to x squared. We're following the work. I did 2 steps at once out loud, but I'm not showing my work because I hope that we know what we're doing. But if not, I can come back and explain this.
You just subtracted or added x squared, right?
Oh, that's an even better way. Yeah, add x squared to both sides. And then finally, I square root both sides, and I get my answer of x is equal to no. Try again.
Positive or negative.
Positive or negative 2.
Right.
You have 2 CVs in this case. Graph them.
Because it's squared.
It is indeed a square. We have negative 2 here, positive 2 here.
Do you have whiteout? Sorry.
Yeah.
Probably not the best idea.
Gio, what were these things that we just found? What are these names?
They are the test points.
We are about to plug in test points, but the thing that we actually found right here,
Are the CVs.
the CVs. CVs. All right, so we found our CVs. Now Gio tells us we're going to do test points. Arrow, what's a good test point that's bigger than 2? Okay, we'll choose 3. Claire, what's a good number in between negative 2 and 2? 0. Gio, what should we do over here?
3.
Careful. Negative 3. There we go. So these are going to be our test points. I'm plugging into the derivative, not f, because I didn't even give you f. If I plug in 3 into the derivative arrow, and then it's going to go Claire and then Gio again. When I plug in 3 into the derivative, I get what?
Negative.
A negative. You are correct. Therefore, what can you conclude over here is happening? F is decreasing. Claire, plugging in 0 gives you a positive, which means F is increasing. And Geo, when I plug in -3,
-3.
Negative 3 squared is? Yep, positive.
Increasing.
Oh, careful. So this is a positive right here.
Uh-huh.
And then times a negative is a
Oh, negative.
negative. And what number do I have? Is it -9? Is it -4? What do we have?
-9.
-9 plus 4 is a
Negative.
negative. Which means you can conclude am I increasing or decreasing?
Decreasing.
Okay, so this is to find the function of that.
I'm not trying to find the function of F. I'm just trying to figure out where F is increasing, decreasing, or where the CVs are.
But like if you were to sketch this graph out with, based on these points, it would be the graph of f, right?
Yes.
Okay.
All right. So again, I'm asking you the same questions, the age-old questions of where is F CVs, where are those guys? Where is the function increasing? And where is the function decreasing? So, CVs, arrow, F increasing is going to be Claire, F decreasing is going to be Geo. F CVs,
So I mean, yeah.
it is indeed you.
X equals -2 and X equals 2.
-2 and X, you can do comma 2 instead of doing 2 different X equals 2. F is increasing where, Claire?
From -2 to 2.
-2 to 2. Including or not including?
Not
Good, not including, and then in inequality notation, in case you like that one better, choose whatever floats your boat. Ooh, not equal to. X is less than 2. And F decreasing, oh, I gave you the hardest one, Geo. You got this.
-3.
So at the CV, that's where it separates. So from here on to the left, I have F decreasing. So how do I say everything to the left of -2?
Negative infinity.
Comma. No, it's -3 is just a test point. You always go up to the CV.
Okay, 2.
So -2, right?
Yes.
And then we also have another F decreasing. Where's that?
Infinity to 2.
Yeah, 2 to infinity. There it is. 2 to infinity. And you could do the inequality notation, which, if I have room down here, inequality notation would be x is less than -2 or x is greater than 2. Woo! So far, so good?
There's a backside.
There is a tiny little backside. Now I'm going to just give you f, and you need to take the derivative and do all of that work. This is like a problem that you'd actually see, well, still not a problem because it's not asking you a specific question. Like the specific question would be, where is x increasing? So just tell me everything. Where is it increasing? Where is it decreasing? Where are the CVs? I want to know everything about this problem. What am I going to do?
Graph.
Graph it. Here we go.
But first you have to make the prime of it.
Let's move this down so we'll have some room to take the derivative. So when I do f prime of x, what is the derivative? That's going to go Geo first, then Claire, and then arrow. Geo, first term.
Oh, you said me first? Okay.
Yes. Take the derivative. 3 is going to come down in front. 3 times 1/3 is
1.
it is indeed 1 x to the power of
2.
2. Good.
Oh.
Claire,
4x.
4x, arrow, 0.
Yeah.
Yep. Derivative of a constant goes away, so we just have that. All right, and then we make our x-axis. There's our x-axis. What are we finding next? The CVs. So we're finding the CVs now. All right, how am I going to find the CVs, Claire?
First take the x out of them.
Take the x out of them? What do you mean by that?
So like
Factor the x.
factor the x out, that's the word.
Factor the x. Okay, so on the right-hand side, I'm going to have
You said it equal to 0.
set equal to 0, and I'm going to factor out the x. X times quantity of
X plus 4.
x plus 4. All right, And using the zero product property arrow, that means and x equals -4. Or if I did this the long way, just to make sure everyone understands the zero product property, I could say x plus 4 is equal to 0, which then implies that x equals -4. Just showing a little bit more of our work. Thank you, arrow. All right, what am I plotting, Gio?
Hold. Okay, you plan the test points.
Careful, I need to plot these first on my.
The CVs.
So where do I plot -4 first or 0 first?
-4.
All right, -4 and 0. What are these things?
CVs.
CVs. Perfect. Claire, choose 3 test points for us.
-2, 1, and -1.
All right, and I'm gonna go. Arrow is gonna plug in 1. Claire is gonna plug in -2. Gio, you're gonna plug in -5, and then you will tell me if the derivative. Remember, you're plugging into this one, not f, is positive or negative. All right, go for it. Arrow 1 is positive, therefore f is increasing. Claire, -2 will be
Negative.
negative.
It's decreasing.
F is decreasing. Oh, there we go. Decreasing. And finally, Geo.
Increasing.
It is increasing because it's positive. F increasing. As a general rule of thumb, whenever you have it in factored form, if the power is odd, this is to the power of 1, power of 1. If the power is odd, you will always switch signs over the CV corresponding to that 0. So this corresponds to this CV. So when I jump over that CV because it was an odd power, I will switch signs. When I look at this CV, which corresponds to the -4, when I jump over that CV because it has an odd power, I will also switch signs. If, for example, I change this to 2, then it would stay negative to negative. Just as a quick little cheat sheet. I'll be going over that again because it is very, very useful to go very fast on these problems. But, I mean, it's more important that you know it than you can do it fast. That's all I have for you guys. The end. No, wait. No, not the end. Conclusion. Step number 4. Where are the CVs? FCVs. Geo, do that one, and then it's going to go Claire, and then it's going to go Arrow. CVs. Geo, where were they?
-4.
X is equal to -4 and
0.
0. Good. Claire, where were the F?
From -infinity to -4, and from 1, or from 0 to
There it is. Make sure you use the word or instead of and, just to be technically correct. And then we have. I know it is kind of unintuitive because you're saying this one and that one, but if you say and mathematically, it means where do they overlap. So or 1 to infinity and arrow f decreasing.
-4 and 0.
Oh, what happened there? -4 to 0 is indeed correct. -4 to 0. Now we're done. All right, good luck on the homework.